Hello everyone. So we're going to be starting a unit eventually on parallel lines and eventually leading into quadrilaterals with parallelograms, trapezoids, rectangles, squares, all of that. But first we need to learn what the word transversal means and how it eventually relates to parallel lines. And this video is mainly going to be talking about vocabulary that I want you to watch this weekend so that you come in Monday ready to go. For those of you that are traveling Thanksgiving, another reason I wanted to do a video is so that you can watch this as many times as you'd like. Even if you are in class and watch it a first time, it's a good resource for you for the vocabulary. So first though, let's figure out what this word transversal means in terms of a picture. So first, if I have two possible lines, A and B, I grab these definitions from your textbook, and what the textbook means by a line that intersects two coplanar lines is these two blue lines do have a chance to intersect. What coplanar really means to me is that they have a chance to intersect. What the transversal is this line that does intersect both of the blue lines, and there's going to be some angle relationships that form from that. And in fact, other relationships that form is if we look at this same picture, I again make my two lines D and E in blue, and in green I'm going to highlight the transversal. So your eventual angle pairs can either be on the left or the right of the transversal, but even more importantly at this stage, outside of the blue lines, or beyond the blue lines, would be called the exterior region, and inside the two blue lines, even if they're not parallel, this entire region would be the interior. And so that vocabulary will also help us as we keep going. Again, here's a second picture, kind of switching things around a little bit. Here are the two lines in the same plane. This time, this green line would be considered the transversal that intersects both of them. So this time, this region would be considered the interior because it's between the two blue lines, and these two regions would be considered exterior because they're beyond the two blue lines. So let's get to the vocabulary here and talk about names of angle pairs related to transversals. So all of these little names are going to come and help us with proofs eventually and within this whole parallel line and quadrilateral section. The first name, not very creative, is called alternate interior angles. So alternate interior angles are a pair of angles formed by two lines and a transversal. The angles must both be in the interior of the figure and must lie on alternate, or in other words, opposite, sides of the transversal and have different vertices. So I wanted to give you the actual definition here, and I want to show you visually what that looks like in this picture. So here is my transversal T. I'll stick with the green color. So my alternate interior angle pairs have to be on opposite sides or alternate sides of the green line and have to be inside or interior of the figure. So what I would say is angle 3 and angle 5 would be considered alternate interior angles because they're on opposite sides of the transversal and within my two lines. And I would also say angles 4 and 6 would also be considered alternate interior angles. The textbook likes to say that if you connect from one line down the transversal and down here, it kind of looks like a Z. Like that one looks like a backwards Z. This one also looks like a Z, just as a way to help you remember it. But I think that the name itself, alternate interior, not creative name, helps you remember what kind of angles we're talking about. The next type of angle is called alternate exterior, which alternate exterior angles are a pair of angles formed by two lines and a transversal again. The angles must both be on the exterior of the figure and must lie on, again, alternate or opposite sides of the transversal. So again, I'm going to highlight my transversal T. This time, the angle pairs that are outside of the two lines would be angle 2, but the angle that goes with it that is alternate side of the transversal would be 8. So I would say that angle 2 and angle 8 would be considered alternate exterior. I would also say that angle 1 and angle 7 would be considered alternate exterior as well. The next pair of angles sometimes are easily forgotten but very important, and they're called corresponding angles. Corresponding angles are a little different than the previous two. They're still made by two lines in a transversal. So again, I'm going to highlight my transversal T. One angle, though, must lie inside of the figure or inside of the lines, and the other must lie on the outside of the two lines or of the figure. The angles must lie on the same side of the transversal but have different vertices. And I feel like especially in this picture, it's important to show you all the possible corresponding angle pairs. One of which, the angle that I would say that goes with 2, where one angle is on the inside, so this angle is on the outside of your lines, but an angle that goes with it that's on the inside, but it's also on the same side of your transversal, would be 6. So it's angle 2 and angle 6 is a pair. I would also say on that same side that angle 3 and angle 7 would be corresponding because one is on the inside of the lines, one is on the outside, and they are both on the same side of the transversal. So angle 3 and angle 7. But wait, there's more. Angle 1 and angle 5 would be considered corresponding. And last but not least, angle 4 and angle 8 I would also consider corresponding. And these have a lot of pairs, but they're very good to know. Same side, or as your book calls it, consecutive interior angles. I'm more of a fan of the same side because same side interior angles, again, are a pair of angles formed by two lines in a transversal. And this, I think, makes more sense. The angles must both be, again, in the interior of your two lines and must lie on the same side, hence the name of this angle pair. So I would say in this particular picture, again, if I highlight transversal T, that should have been in green, then some same side interior angles would be 3 and 6 because they're both inside and both on the same. So angle 3 and angle 6 would be a pair. And I would also say that angle 4 and angle 5 would be a pair. 1, 2, 8, and 7 are all on the outside, so that would not apply to interior. However, the last set is same side exterior angles, or again, as the book calls it, consecutive exterior angles. Same side exterior angles, again, are formed by two lines in a transversal. The angles both must be on the exterior of the figure and must lie on the same side of the transversal and have different vertices. So, angle 2 and angle 7, different vertices, same side, both on the outside of the two lines. So angle 2 and angle 7 are a pair. And I would say there's one more, angle 1 and angle 8 also fit this criteria. So with that all said, I would like you to try these problems here on your own. I would like you to write down what you think, what type of angle pair, alternate interior, alternate exterior, corresponding, same side interior, or same side exterior. What kind of angle pairs do you have here? So I'd like you to please pause the video, try them, and when you come back, I will walk through them and we'll see how you did. All right, guys, so to check your work, the first example I said were same side interior, because if you take a look at my picture where I marked the two blue, 2 and 6 are both within my two lines and on the same side of the transversal. So I said same side interior made the most sense here. The second pair, 4 and 8, look like they are on opposite sides of the transversal or alternate sides and are both exterior or outside of the two lines. So I said alternate exterior angles. The third pair I put as green dots, look like one's on the inside, one's on the outside. The only pair that's true for is corresponding. And then the 2 and 5, which I put two little purple dots, they look like they are both inside the two lines, but opposite sides of the transversal. So I said alternate interior angles. All of the interior angles were 1, 2, 5, and 6, and all the exterior angles were 3, 4, 7, and 8. So this next one, I think I might do a few of them and then let you try some as well. I think this is a really good way to start because you might notice that you could view in this picture that you have many different lines and many different transversals, for instance. If you looked at lines L and M, you could say that this line here and this line here would both be considered transversals. But if you change your perspective and you thought that these were the two lines, or excuse me, if you thought that these two parallel lines were the two lines, you could view L and M as transversals. So really you have 4 different options here based on how you turn your head. So I want to go through a few of these. So if I looked at angles 1 and 4, oh, I love that. This is just review. If anyone's looking at these two and saying those look like vertical angles, I agree. I thought I'd throw in a little review. So these first pair are vertical. That shall not go away. The next pair, let's see, the next pair, 2 and 10. So let me mark those. 2 here and 10 here. So what I notice then is if I'm looking at these 2 blue angles, these are the 2 lines that I'm looking at. And this would be considered my transversal. Let me make that in a different color. So if I looked at these 2 angles, one is on the inside and one is on the outside, and they are on the same side. So I would say the only thing that fits would be corresponding angles. Let me erase that. And it's good just to draw your picture. If you want to keep erasing like I am, that would be good. 4 and 9. Oops. So angles 4 and 9. So again, I notice that these are on opposite sides. So I'm guessing that this is probably my transversal, and these are my 2 lines. So if I look at angle 4 and angle 9, they look like they're on opposite sides of the transversal, and they are both within the 2 green lines. So I would say alternate interior. So again, what I'd like you to do is please pause your video. Please try these next ones on your own, and I will go through them when you come back. All right, guys, so to go through this first one, 6 and 3, if I mark those 2, what my perspective is telling me is that this is going to be my transversal, and these are going to be my 2 lines. So if I take a look at my 2 angle pairs, if any of you said alternate exterior, I agree with you, because you have on opposite sides of the transversal and both on the outside of the 2 blue lines. The next example, I keep erasing each time just for visual purposes. The next example for 14 and 10, I think this time that this is my transversal. So these would be my 2 blue lines here and here. So if I'm looking at these 2 angle pairs, one looks like it's on the outside of the blue lines, one looks like it's on the inside of the blue lines on the same side. So I would say, just like the second example, corresponding angles is probably the best explanation. And then 7 and 13, that would be here and here, which I notice again, my transversal changed. That's probably going to be where my eye goes. These are going to be the 2 lines that it intersects. If I look at 7 and 13, they look like they're on the same side of the transversal, both in the interior of the 2 green lines. So I would say that this is same side interior angles. All right, guys, so that is an introduction to some of the vocabulary. So feel free to watch this video again if you'd like, but I'm going to start fresh with a bunch of interesting things with these angles. In fact, I'm planning on using GeoGebra to find a bunch of relationships between parallel lines and these angle pairs. All right, I'll see you in class. Thanks for watching.